Welcome back. In this video series, we're going to talk about isomers. So, in the first section, we're going to look at two different types of isomers. You've got conformational and structural. So, conformational isomers are technically the same compound. We can have the same compound shown in many different ways. And in order to determine if you have an isomer, the first thing you should do is check the molecular formula to ensure that they are indeed isomers. So isomers should have the same number of every type of atom, same number of carbons, hydrogens, oxygen, nitrogen, and whatever else is in there. So if we look at the total number of carbons in this first structure, we have 1, 2, 3, 4, 5, 6 carbons. Okay, so that is a C6. And then if you were to add up all the hydrogens, you've got 5, 6, 7, 8, 9, plus 6 is 15. And then we've got 1 nitrogen. Okay, and then if you count on the second structure, we also have 1, 2, 3, 4, 5, 6 carbons. We should have 15 hydrogens. And 1 nitrogen. Okay, so as long as those molecular formulas are the same, then we know we have an isomer, and now we've got to decide, is it conformational or is it structural? So we've got to ask, are they the same compound that are just pictured in two different ways? If they are, then they're conformational. So we want to make sure that they have the same number of carbons in the longest chain, and that all the functional groups or the branches are located on the same carbon numbers. So the way that I do this is that you either want to grab a pen or a highlighter, and what we're going to do is highlight starting at the end of a carbon chain. So we could either start technically here, here, or we could even start up there. So in this first example, we're going to keep it easy, and we're just going to start from the left-hand side. Technically, I want to always start on the side that has the functional group closest to it. So because this has the nitrogen here, I want to start on the left-hand side, and I'm going to go across and not pick up my pen. Okay? So without picking up my pen, I can count 1, 2, 3, 4, 5 carbons. I can't catch that carbon at the top because I would have to backtrack or I would have to lift up my pen, and so that doesn't count as part of our longest chain. Then next, I'm going to number those carbons, and I'm going to start numbering on the side that has the functional group. Okay? So on the second carbon, I have a nitrogen, and on the fourth carbon, I have a CH, or a CH3, a methyl group is what we call that. So in the second structure, I'm going to do the same thing. I'm going to grab my highlighter, and I'm going to start on the end that has that functional group, that has that nitrogen. And then I'm going to drag it without lifting up my pen and without backtracking and catch the longest chain I can. And then I'm going to go and I'm going to number the carbons starting on the side that has the functional group, which is the nitrogen. So notice how in both examples I have the longest carbon chain is 5 carbon chain, or a 5 carbons in the longest chain. And then on the second carbon, so we can say on carbon number 2, there's the nitrogen. And then on carbon number 4, in both pictures, we have that CH3, that methyl group. Okay, so we have the exact same carbon, the longest carbon chain length. We have the nitrogen on carbon 2, and we have the methyl group, the CH3, on carbon number 4. So these are the same compound, and therefore they are conformational isomers. Okay. Now, the other type of isomer we're going to look at are structural isomers. This is where they still have the same molecular formula, but they have a different connectivity of atoms. So this means that either the carbon chain will be shorter or longer, depending on the isomer, or you may have the functional groups located on different carbon numbers. So again, our first step is to count up the number of carbons and hydrogens in each one of these structures. And if you count them in each structure, you're going to find that you have 6 carbons, you have 14 hydrogens, and you have 1 oxygen for all 3 of those structures. Okay, so because they have the same molecular formula, we know we're dealing with some type of an isomer. The question is, are any of these the same molecule? Okay, so again, what I'm going to do is I'm going to find the longest carbon chain without picking up my pen. So here, if I start on the left-hand side, I'm going to run into an oxygen, so I don't want to start there this time. So instead, I can choose to either start up top, but if I do that, I'm not going to catch as many carbons, right? I'm only going to get 3 carbons there. So I'm going to start on the right-hand side. And I'm going to go until I reach that oxygen. And so I get a total of 4 carbons in that chain. And then off of 1 carbon, I've got the oxygen with a methyl group, and off of another carbon, I've got a CH3. So if I'm going to number this 4-chain carbon, I've got to start on the side that has the functional group. So I'm going to start on the side that has that oxygen and go 1, 2, 3, 4. Okay, so on carbon number 1, I've got a oxygen with a CH3, and on carbon number 2, I've got a methyl group. Now, in the second example, going to go back to my highlighter, and again, I want to get the longest carbon chain possible. So if I start here, I can click and drag my pen all the way up and catch all of those carbons. And if I number them in order, starting with the side that's closest to that oxygen, I've got 1, 2, 3, 4, 5 carbons. So I can already tell that this is not the same compound because I've got a 5 carbon chain length, whereas in the first one I only had 4 carbons. So already I can tell that these have to be structural isomers. Okay, and then I do still have that oxygen with that methyl group coming off of carbon number 2, but in the first example it was coming off of carbon number 1. So again, two different compounds. So in this last example, I think you can already tell that it's going to be different. Here, I can click and drag and catch all 6 of my carbons. Okay, and so if I start with the side closest to that OH group, I would have to start on this side and go 1, 2, 3, 4, 5, 6. And so that's now an OH group that's on carbon number 3. It's a completely different functional group that's coming off of it. Okay, and you've got a 6 carbon chain long. So all 3 of these are structural isomers. They have different carbon chain lengths for your longest chain, and they have different functional groups coming off of different numbered carbons. And then the last type we're going to look at are unrelated compounds. So these tend to be the easiest because as soon as you look at those molecular formulas, they're going to be different. So if I count up the number of carbons in both of the structures, I do have 4 carbons. But on the left-hand side, this is, remember, cyclobutane. If we add up all the hydrogens, you've got a total of 8. Remember, you have twice as many hydrogens as carbons with your cycloalkanes. But with a standard alkane, a regular butane, we've got C4, and if you count up the hydrogens, you'll see that it's H10. So different molecular formulas, they're automatically unrelated. And then the last 2, if we count up, we've got 3 carbons on both of these. so it's a C3. But when we count up the number of hydrogens in this first structure, you should have 3, 4, 5, 6, 9. And then we've got a nitrogen and oxygen. Remember, we go in alphabetical order, so N and then O. Okay, and then on the last one, still a C3, but if you count up the number of hydrogens, now we only have 7. And then N and O. So the fact that the two hydrogen numbers are different in each one of these cases means that they're going to be unrelated. Okay, so in the next video, we will go through some example questions where we try to decide, are they conformational or structural isomers, or are they completely unrelated?